Welcome to today's chemistry lecture. This is the last lecture of this chapter, in which we are going to study the numericals from the exercise. There are almost 8 numericals which are all about the topics that we have been learned throughout our chapter. So let's see step by step, one by one, every numerical. Here comes our first numerical, which is calculate the number of moles, volume and number of molecules in 4 gram of CH4. In first step, we will find the number of moles by using formula moles is equal to mass divided by molar mass, that gives us answer of 0.25 moles. In the second step, we will use the RTP procedure to find our volume in 4 gram, which is equal to 6.0 decimeter cube. In the third step, we will find number of molecules. By putting values, we will give an answer of 1.505 into 10 की power 23 moles. So by using all the third step, we can easily find our moles, volume and number of molecules in 4 gram of CH4. Numerical number 2. What mass of NaCl need to be dissolved in 150 centimeter cube of a solution if the concentration of the solution is 0.4 decimeter mole per decimeter cube. So in this numerical we will find the mass of NaCl that we need to dissolve in 150 centimeter cube of 0.4 concentrated solution. So first of all, we will convert decimeter to centimeter cube to find moles. In second step, we will find molar mass, and then after these we will put our values to calculate mass into mass formula, which gives us the answer of 3.51 gram, which is need to be dissolved to solution of 0.4 mole per decimeter cube. Third numerical, which is find out the percentage of sodium in NaHCO3. In first step, we will find molar mass of NaHCO3, which is 84 gram per mole. And now we will find the mass of sodium, which is 23 gram per mole. By using this value, we will put this value in our percentage of sodium formula. The formula is percentage of sodium is equal to mass divided by molar mass multiplied by 100. By putting values in this formula, we will get an answer of 27.38 percentage. So the percentage of sodium in NaHCO3 is 27.38%. So we can easily find our percentage of sodium in NaHCO3 by properly using our formulas. Fourth numerical, which is a sulfide of iron contains 1.926 gram of sulfur and 2.33 gram of iron. Find out the empirical formula of its compound. So in this numerical we will find our empirical formula. So in the first step, we will find mole of each element. After finding the mole of each element, in second step we will divide with the smallest value to get ratio. So after getting ratio, we will multiply by 2 to get whole numbers, which are Fe is equal to 2 and S 3. So the empirical formula is F2S3. Numerical number 5. A compound contains by mass 40% carbon, 6.71% hydrogen and 53.3% oxygen. A 0.320 mole of this compound weigh 28.8 gram. What is the molecular formula of this compound? So in the first step, we will find the empirical formula. After finding the empirical formula, in second step we will find our molar mass of this compound. After finding molar mass in second step, in third step we will find molecular formula by putting values in our formula of N is equal to molar mass divided by empirical mass, which is 3. So the molecular formula will be 3 multiply into CH2O, which is equal to C3H6O3. So the molecular formula will be equal to C3H6O3. The sixth numerical, which is a equation, is stated: if you start reacting 12 gram of hydrogen with 64 gram of nitrogen, which will be the limiting reactant? By using our given equation, we will find our limiting reactant. So in first step we will convert given masses into moles. After finding our number of moles, we will determine the required ratio. After requiring the ratio, we will see that to fully react 2.285 moles of NO2 we will need 6.855 moles of H2. Since you only have 6 moles of H2, there is not enough H2 to complete the reaction with all available nitrogen. So hydrogen is the limiting reactant because its number of moles is lesser than the number of moles of nitrogen. So hydrogen will be declared as limiting reactant due to less amount of its moles, which decompose early than the nitrogen's molecule. Here comes our seventh numerical, which is when 305 gram of AgNO3 is reacted with excess of MgCl2, it produces 23.7 gram of MgNO3 to what is the percentage yield of the reaction? So in first step we will write an balanced chemical equation. In the second step we will find our molar masses of the compounds. In the third step we will calculate the number of moles of a reactant. In the fourth step we will calculate our theoretical yields. By calculating theoretical yields, we will find our theoretical moles of MgNO3. After this we will find our theoretical mass. By getting all our values, we will put these values in our percentage yield formula, which is percentage yield is equal to actual yield divided by theoretical yield. By putting values, we can easily find the answer of 17.8%. So the percentage yield of this reaction is 17.8%. Here comes our last and eighth numerical of this chapter. A sample of metal has a total mass of 3.66 kg and contains 2.45 kg of gold. What is the percentage purity of gold in the sample? So let's see the solution. For finding the percentage purity, we will use the formula of percentage purity, which is percentage purity is equal to mass of pure gold divided by total mass of sample multiplied by 100. So our putting values, which is 2.4 kg of gold and 3.66 kg of sample multiplied by 100, we will get an answer of 66.94%. So the percentage of purity of gold in sample is 66.94%. Here today our lecture is complete with this chapter completion. So hopefully you can find it easily to solve at your home.